Hi, everyone, and welcome to the webinar on improving testing coverage with automated code coverage analysis. My name is Nick Medeiros. I'm a technical marketing engineer at FrogLogic, and today's webinar is all about code coverage analysis with Squish Coco. We'll chat about ways to improve your application's quality, enhance your team's testing efficiency, and in general, talk about test smarter approaches that come with using a code coverage tool. The way that the webinar will work is that I'll go through just a few slides on an intro to Coco and how it works, and then we'll jump into some demos. I will flip between the slides, the command line, and our example application throughout the webinar. You should all see a questions box or a chat box where you can type in questions at any time throughout the webinar. We'll wrap up today's session with a dedicated Q&A portion. My email is on this slide. And you should feel free to reach out to me with any questions you have after this webinar or about Coco in general. So there's a lot to cover today, so I'll stop with the intro and we can get started. So first, I just wanted to offer a few notes about who we are for folks who don't know. FrogLogic was founded by two guys, Harry Porton and Reggie Settlebauer, back in 2003, with an initial goal in mind to create an automated GUI testing tool for applications built with the Qt framework. We've since grown from that first offering to have a software quality suite, which we call Squish, that includes the Squish GUI Tester, a cross-platform automated GUI testing tool, Squish Coco, a code coverage analysis tool we'll discuss today, and most recently launched Squish Test Center, which is a test result management platform. Our products support nearly 4,000 customers in anything from automotive to medical to aerospace. We're used at small startups to large corporations and everyone in between. And we're headquartered in Hamburg, Germany, with additional offices around the world. I'm in Boston. So this slide sort of summarizes Coco in pretty broad terms. I've written here cross-platform code coverage analysis toolchain. And what does that mean? So the idea behind code coverage is that source code which has been hit by tests offers a lower chance of defects being found in the final product. And Coco can analyze and identify code that's been executed by our tests. And with that, it can also report on the untested code, meaning it'll tell you where you might need to refocus your testing efforts in order to get higher coverage from your tests. Sometimes there are critical areas that need to be covered that aren't being covered, and you won't know that in pretty large programs without a code coverage tool. Coco can also identify redundant tests, so it'll tell you tests that are covering the same code more than once, and this helps you to write more efficiently and also minimizes the time spent in a test batch. Coco can also identify dead code, which is logically unreachable code, which is a static analysis, but Coco is mainly for dynamic analysis. And that's all code coverage analysis, but Coco can also measure code complexity, which we'll talk about a little bit later when we discuss safety critical apps. But basically that gives you an idea of the level of maintainability and testability of your code. And new to Coco 5, which is our last major release, Coco has a built-in function profiler, which you can use to assess application performance. At its core, it's like any other function profiler. It'll give you data on the frequency and duration of function calls associated with your test executions. And you can use this data to figure out if you have any avoidable performance slowdowns or if you need to refactor an algorithm in your code. And what's really cool about the function profiler is that there's a feature built in where you can compare product versions together. So you can upload two binaries, two different versions of your source code, and compare them together. And Coco has other features for optimizing your testing, and we'll touch on a few later on. But first, I'd like to cover how Coco works with applications. And the first step in getting your application to work with Coco is to instrument it. So here is number 1 is for instrumentation, number 2 is execution, and 3 is analysis. So on the left, you see sort of a modified program compilation. we see the usual stages of getting a binary: the pre-processing stage, compiling, assembly, and linking. And Coco works by inserting statements into the pre-process code, and at the linking stage creates an instrumentation database, what we call the CSMES file. So when you have that binary and you execute it, it creates a second file called the execution report, or CSEXE file. And if you take these two data files and feed them into a program of Coco called the coverage browser, you get your coverage report. So the coverage scanner you won't see because it's sort of a backend program of Coco that handles the instrumentation. And the coverage browser you will see because it's Coco's main UI. So that's about it with instrumentation. The nice thing about Coco is that the instrumentation is pretty automatic. You don't need to mess around with your program source code to get it working. On this slide, some necessary background on Coco support is given here. People ask, will my platform be supported? We offer pre-built packages for the popular platforms, like of course, like Mac OS and Windows and Linux. But we also offer a platform support package for targeting additional platforms using a cross compiler. These include mobile operating systems like Android, embedded Linux, embedded Windows, real-time operating systems, and more. As for our compiler support, what I've written here is a very, very short excerpt of what we actually support. There's a larger, more complete list on our website, but even that's not complete. So we encourage you to contact us if you don't see explicit support here or on our website for the compiler that you're using. And the hardware of the target system can basically be anything that any of the supported compilers can target. So you can imagine a pretty wide-reaching platform support with Coco. As for language support, this is changing. Right now we support popular languages from the C family of programming languages, in addition to QML and Tcl. And adding languages to Coco support is, of course, an area of active development, and it's driven by customer demand. And I'd like to just pause and bring up a quick poll for you guys about language support you'd like to see in Coco, because we're always interested in what customers want. So I'm going to launch this poll right now. And you should be able to vote on language support you'd like to see supported in Coco. Either Java, JavaScript, Python, or PHP. Okay, thank you. Looks like we got 100%, almost 100% voted. Let's come back here. Oh, sorry about that. Thanks, guys. Like I said, if you don't see, if one of your languages was not listed in that poll or it's not listed in the existing support, please email me and let me know what you'd like to see. So last slide before we jump into a demo. Coco supports a number of metrics for reporting on the coverage. Many of these are probably familiar to you, like function and line and statement coverage. We don't have time to go through each in depth, but some more complex ones like MCDC and MCC deserve an explanation. So in MCDC, or modified condition decision coverage, it's like condition coverage, except every condition in a decision must be tested independently in order to reach full coverage. And in multiple condition coverage, all combinations of truth values in each decision must occur at least once to reach full coverage. These two coverage metrics are not activated by default when Coco reports on the coverage. You have to specify those explicitly when you instrument your application, and that's because they're more complex metrics that do cause a little bit of overhead. But these metrics have different implications when we talk about safety critical applications, which we'll discuss in a later portion of the talk. One thing I'd like to mention is that this list is ordered in such a way that if you have, for example, statement coverage, 100% statement coverage, then automatically you have 100% line coverage and every preceding coverage metric in the list. Okay, I've talked enough. So we should see Coco in action now. So we'll work with a C++ example. This is a command line example. It does not have a GUI, but we will see a demo later on with a GUI. And this example is in every Squish Coco package, so you can find it there. It's a C++ parser, which is basically just acts as a calculator for basic expressions. So you could do like 1 + 1 and it'll give you 2 and so on. And what we've done in this example is we've written a small set of unit tests testing different functionality of the parser. So in this demo, I'll show you how the instrumentation works, how to compile the program, and we'll get a first look at results in Squish Coco's coverage browser. So let me get out of here and open a terminal. So my terminal is messy. So I'm in my parser directory, and I just want to give you a sense of how the program works. So I'll compile it with make and let that run. And this is not instrumented. This is just the program on its own. And it gives us a parser executable. So we'll run that. And we can just enter in simple expressions. So 1 + 1 is 2, 3 divided by 4 is 0.75, 4 factorial is 24. It also has some error handling. So if I type in bogus input, I get unknown variable and so on. So I'll enter to exit out of that. I'll clean this up. And we'll just take a look at our unit test file. So like I said, we've written a number of unit tests. And if I scroll a bit, you can see we're testing out different functionality of the parser, like minus, multiply, divide. We have some error handling and so on. So we have a total of 14 tests. And you'll notice that this is written in the CPP unit framework, which of course is works fine with Coco, just like pretty much any unit test framework. So let's move on to instrumentation. So the way I have the instrumentation set up is that it's handled by a small shell script. And you see a number of export statements here. The first export statement manipulates the search path to a directory containing compiler wrappers. These wrappers are actually symbolic links to a backend program of Coco that I mentioned earlier, the coverage scanner. And the coverage scanner, to give you a little bit more background on that, it's a program that inserts instrumentation code into the preprocess program, and then at the end compiles and links the project file in the same way as a normal build. What's nice about Coco, like I mentioned earlier, is that this process is automatic. We're not messing around with our actual source code. And when the compiler wrappers are executed, remember they're linked to the coverage scanner. They create the instrumented version of the source code and then run the original compiler to compile it. The remaining export statements are additional flags to the compiler wrappers. The first one, cs-on, just activates the code coverage. The next two here, remember I mentioned that MCDC and MCC are not on by default. So these two flags here are just activating those coverage metrics. And you see here in the last three, these exclude flags, we're excluding the source files of the CPP unit framework. And this is just so that our coverage is not including the CPP test framework. You can imagine that if we did include those, our coverage rates, when Coco reports on them, would be artificially low. And so since we're not writing tests against the CPP unit framework, we're excluding those. So I'll X out of here, and to compile the program, all we need to do is call the script with make and our tests. So that'll take a second. While that's running, I do have one more poll that I'd love to get your information on, your input on, about your IDE or your editor that you use. So I'll just launch that while that's compiling. If folks could answer the editor or IDE of choice that they use, either Visual Studio, Qt Creator IDE, Eclipse, or Visual Studio Code, that would help us. Okay, great. We got 100% voting there. That's still compiling. Okay, so that ran. So remember I said earlier, when I was going through the instrumentation diagram, when we instrument, we have the CSMES file. So if I list that, I should have, and I have it right there, unit test.csmes. And because we executed tests against the application, we also should have a CS.exe file, and we do. So we'll take those two data files and we'll open those up in the coverage browser. I've done that in just a short shell script, but it's really just a one-line command. So webinar unit tests. So we'll give a name to those. The status you can list as pass, failed, or unknown, or if there was an incident or requires manual checking. We'll leave those as unknown. You can choose to delete the execution report after loading. We won't do that. And any executions with the same name will be merged. So we'll load those, and you can see all 14 of our tests loaded. And the way our unit tests were set up is that each test name propagated to Coco along with its pass failure status. So we'll import those. And this is Coco's coverage browser UI. So right away, you can see the large window here, which is the source viewer, and it's colored by the source code is colored by the execution status. So green indicates that code was executed. If I click on that and hover over it, you get a tooltip saying executed 65 times by 12 tests. Red indicates that the code was never executed. And orange executes partially executed conditions or decisions. So we see here that if I hover over this, we get the truth table saying that true was never evaluated and the false condition was evaluated. So up here, you can cycle between the metrics that you want displayed. So let's say we go to function coverage. We see a pretty high percentage, and that's because the way Coco reports on function coverage is if a function is considered executed if at least it is called once, and it doesn't matter if its internals are not executed. So for in-depth coverage analysis, function coverage is probably not so good, but as a sort of surface level analysis, it's okay. And if we cycle through line, we get a little bit less coverage, and statement, we get even less. So let's go back to condition. Let me just get this a little bit smaller so we see the executions window. Here we see our execution window. So these are each of our unit tests that we executed, and also the coverage percent for each of them, their pass failure status, and the execution time. So, so you can get a sense for how long each of your tests took. Here in the functions window, you can double click and it'll bring you to a certain function. So for example, let's go to factorial. Factorial is completely in red, which means that it was never covered. And let me just, so we see that no tests were written for the factorial function, and that's true. If we take a look at our unit test, we skipped over that. And note that looking at the source code, we see that we didn't test a whole number factorial, a decimal factorial, and a 0 factorial function. So those 3 tests would be needed to get full coverage. Another thing you can do in Coco is you can jump between what you're looking at. So let's say you only wanted to look at dead code, for example, so code that is logically unreachable. If you click on the arrow button, it'll jump to the dead code. So you can cycle through that. Also, if you wanted to look at unexecuted code, you could do the same thing. So here, we're in parser.cpp. These cases were never evaluated. Let's look at error.cpp and jumping to unexecuted. We only tested error handling in a couple cases, and our other error handling is not being tested. So if we cycle through those, we'll just jump line by line. And last thing I want to show in the coverage browser is that you can generate a report. So Coco supports HTML and CSV reports for sharing these with folks on your team who don't have access to Coco. These are human readable reports. We also have reports for Emma XML and Cobertura XML and also in JUnit. But let's look at the HTML report. You can also customize what's shown. Also in the source tree here, if I were to deselect one of these, it would not show up in the report either, but I have everything selected. So, and the report basically summarizes everything that you see in the coverage browser, but in an more easily navigable way. So if you look at the sources, you can go to a list view. We see our source files and the condition coverage, and you can click on those and it'll give you a view of the source code. It'll also color that in the report. You can also do the same thing for functions. It'll organize them by coverage. So you see what's not been covered, and again, it'll give you the lines where they are, and if you click on them, it'll bring you to that. So here's the factorial. And code 2, you can get a list of the dead code, the unexecuted code, and so on and so forth. So the reports are just really to summarize for people on your team who may not have Coco, and you can share them more easily between development and QA. One last thing I want to show in the coverage browser is you can add comments. So if I right click on a line, you can add a comment. So add my comment here and click OK. And in your report, all those comments will propagate. So let's say if we go to the factorial function, we right click here, add comment, must add test for 0 factorial, and something like that, and add that there. And when you generate a report and send it to folks on your development or QA team, they'll be able to view those in one concise file. So that's what I want to show in the coverage browser for now. Let's get back to the presentation. There were one thing I wanted to show is test case prioritization, which is a optimization technique where if you consider a development scenario where you don't have enough time to run a full regression suite, but you want to do some level of testing, what you can do is you can schedule tests to maximize the coverage efficiency. So basically, you optimize the order of the tests in order to get the most coverage out of the fewest amount of tests. And in Coco, you can do that literally with a click of a button. So if I go to View, Optimize Execution Order, here, all we need to do is click on Compute, and you see an ordered list of tests. So these are our unit tests ordered that we ran against our parser application. And the first test, test var, we see a coverage of 31.8%. That means that with one test, that is the highest amount of coverage that we can reach with all of our tests. And the next test in the line is that which gives the coverage, that which gets the coverage a little bit higher. So if we add test syntax, our coverage then becomes 35%. So these are additive, so it's cumulative coverage. And it's a good way to get some kind of coverage testing done when you don't have enough time to run a full test suite, which could take hours or days. You'll notice here that we had 14 unit tests, but only 11 of them are showing up. One of our tests did fail, but also 2 of our tests are redundant. So Coco recognizes the redundancy and ignores them from the optimized execution order. So it really gives you truly the optimized ordering of tests for getting the maximum amount of coverage in the shortest amount of time. And the time required is given in this column here, and of course you can see it's accumulated just like the coverage. So that's what I wanted to show there. Let's get back to a couple slides. Another optimization or testing approach that I wanted to talk about is test impact analysis, which is also referred to as patch analysis. So let's talk about a common development scenario. You have a last minute patch that you're going to check in, and you don't have enough time to run the full test suite, but you want to evaluate at some level the riskiness of the patch before your product is released. And Coco couldn't help with that. The way it works is you first execute your full test suite against your source code at least once with Coco. Then you develop the last minute patch. Maybe it's a hotfix or maybe it's a last minute feature request. Coco has a tool built in which will determine the tests which cover the change code, and you can ask it to output this list of tests. So in that sense, Coco determines which tests exercise the change code brought by the patch, and you run only those. So you feed those into your testing framework. And this is good when you don't have enough time to run a full test suite, but like I said, there's some risk assessment that needs to be done. Before we get into our GUI demo, I just wanted to touch on Blackbox testing, which is good for teams that have distributed or outsourced QA teams. So at many companies, source code is under high security, and even individual developers do not have access to the full, all the routines in the source code. And if you're working with a distributed team all over the world, or a QA team that you outsource to another company, it's important to keep your source code secure. And the example that we showed earlier had the source code in plain view in Coco. What Coco does is it allows you to generate what's called a black box database. And this is done in just a click of a button. And what a developer with master access to the source code can do is ship an instrumented build to QA for their testing and give them a black box database. What QA will do is they'll do their tests they'll do all their test executions as normal. And in the black box database, they can include things like execution comments. It'll record the time of each test. It'll record the state of each test, whether it's passed, failed. It'll also give the coverage percent of each test, but it won't show the source code. And once all the individual QA team members have executed their tests in the black box database, what the master developer can do is merge those into one report with the source code view. and get a full picture of the coverage. So if you're working if you're working under conditions of high source code security, or you do have a QA team that's dispersed and outsourced, Blackbox database testing might be a good feature for you. Moving on to a next demo. So far we've seen Coco with unit tests, but I don't want you to think that Coco is only for unit testing. It covers other testing strategies like manual testing, functional GUI testing, automatic testing, and we'll demo getting the coverage from GUI tests in this example. The automated testing framework that I use is the GUI testing framework that I'll use is our own Squish. This is not a webinar on Squish, but if I could just summarize it in a few seconds, it works basically through property-based UI control recognition, although we do offer image-based testing. And the example demo that we'll use is an example from the Qt company. It's a text edit application built using the Qt framework. And I want to show this with Qt because we have new to Coco 5 support for getting the code coverage of our GUI tests when using Qt applications in an automatic and streamlined manner. So let's do that. So let me pull up a terminal again. I'll get out of the coverage browser. And we'll go to our text edit example. And so I've already instrumented this application, but it's, again, a C++ application, and it's a Qt application. In order to instrument it, basically you just have to have QMake be instructed to use the coverage scanners wrappers for compilation, but nothing crazy. So you see that I have an app bundle because I'm on Mac. So if I go in here, I have my app bundle, and I've executed this already in the past. So I have a CSE, CSEXE, and CSMES, but I just want to show you that I have the text edit app, and that's my instrumented application. So let me pull up Squish. So this is the Squish GUI tester. Like I said, this is not a webinar about automated GUI testing, so I won't go too much into it. But basically, I just have a script written in Python that identifies the UI controls in the Qt framework. What I'd like to do, let me just launch this application to get a sense for what it does. It's a simple text editor. So you can, write text here, you can bold, italicize, save it, and so on. And what we want to do in this example is we want to write a GUI test that checks for the file save as functionality. So I'll quit out of that. And I've done that in a simple GUI test written in Squish. So I'll walk you through it. First, it starts the application. It clicks the button to save, chooses file save as, sets the file name. Here I have file1 demo, and then quits the application. And Squish requires that you have an application under test set in the settings. So if I go here, if I go to the settings, here my application is set as text edit. And this is the instrumented version of the application, the instrumented version with Coco. And the way the automatic integration works is that if I execute my GUI test through Squish, it'll automatically output a execution report that I can feed into the coverage browser. So I'll first so we have it clear, I'll remove my CSEXE file. So let's just play this test. You can see it in action. You can see I try to file save as, set a file name, save, and close the application. And that's it. You can see that the test passed. And if we look in our file directory, you can see that we have a CS.exe file automatically generated from Squish. So I'll go ahead and I'll open it up in the coverage browser. So webinar GUI test 1, and it passed. So we'll click next. We see that our test passed. Import it, and let's open up. Oh, sorry. Let's open up our text edit file, and we'll scroll through to our file save function, and we'll take a look here. So with one GUI test, we got 85% condition coverage. And if we take a look, we see, if we hover over it, we see the if success condition, the false case has never been evaluated. This means that we were never unsuccessfully able to save a file. So our GUI test, one GUI test, was not sufficient to get full coverage. So we can use Coco as a guide for testing smarter in order to write a more informed second test, rather than just blindly testing more. So let's go back to Squish. Now, in a second test, I've done exactly that. I try to unsuccessfully save a file, and all that means is that I need to set an illegal file name. So if I write here, I give illegal on Mac OS is just a / before the name. So if I run this test, it'll do the same thing. It'll open up my file, my application. It'll try to illegally save it. And Coco detects that something changed. So let's give a new name to this. Our second test imported. Now let's look back at file save, and look at that. We have 100% coverage. So just to summarize, what we've done is we first wrote a GUI test to cover the file save capability in the GUI. We use code coverage analysis to inform us to get more information on what was covered and what was not covered. And we use that to write the minimum required testing in order to fully cover our file save functionality. And we did that with only 2 tests. If we look at file save as, we see it's deserving of more tests. And this just tells us that we need to check saving with an ODT file extension and an HTML file extension and an empty file name. And if we do that with additional GUI tests, we'll have full coverage. Okay, I hope that was clear, not too fast. Again, if you have any questions, feel free to write them in the chat. We'll get to them soon. Last couple things I want to talk about before we jump into safety critical software is continuous integration. So the adoption of the DevOps process in today's teams has really bolstered the use of continuous integration for improving quality control in ever-shortening release cycles. And with our code coverage tooling, we'd want to integrate our tool with our CI system as part of our build and test infrastructure to get fast feedback on the coverage. And of course, with Coco, you can do that. Here I've named just a few CI systems that we have ready-made integration support for, but let's take Jenkins as an example. If you use the Jenkins plugin, you can view the updated coverage over time. And what's great about it is with new check-ins, you can also set thresholds for marking a build as pass or fail. So the idea is that with the Coco integration, the Coco Jenkins integration, you could say we want X% of coverage for each build with new commits and fail the build if it doesn't reach that coverage threshold. And with this integration, it automatically gives you a report and gives you that fast feedback. We do support integrations with other CI systems not listed here that can be achieved with a set of command line tools. The last part about what I wanted to talk about is safety critical software. So coverage levels are important when we talk about safety critical applications. because different regulations and legislation for these standards, let's say in automotive applications, medical device manufacturing, software involved in railway systems, they have different requirements for their respective safety critical standard. On this slide here, you see the different safety integrity levels, SILs, for the ISO 26262 standard, which concerns functional safety in automotive systems. And this table is for coverage at the unit level. And you can see on this table that in this standard, 100% decision or branch coverage is, with the plus plus sign, means that it's, quote, highly recommended for the B, C, and D SILs, and 100% MCDC coverage is highly recommended for the D SIL. Note that the D level is for systems where human lives are at risk for fatality. And another important focus on this standard specifically is, quote, it's the standard's enforcement of low complexity, which is another way of describing the difficulty in maintaining the code. And measurement of code complexity, Coco uses the McCabe cyclomatic complexity metric. It gives you a picture of the number of branches, switch case statements, and loops in the source code. And this is important because code with a McCabe cyclomatic complexity under 10, which is its heuristic value, means that the code is structured and well written, offers high testability, and results in low long-term costs. So we see growing use of Coco in both its code coverage analysis and its code complexity analysis, where safety critical applications are concerned because of these of the structural coverage metrics required. Last thing I want to talk about was tool qualification. So this goes back to safety critical applications. So the same standards that I mentioned, like automotive and medical and railway, it's not just about the code, but they also mandate that the tools involved in the software testing, like Coco, be qualified in order to reach that safety standard. And the idea behind tool qualification is to gain confidence in the tool. So we at FrogLogic have seen growing requests for tool qualification kits for both the Squish GUI tester and for Squish Coco. And these kits, the way they work, they're not a one-size-fits-all kind of thing. We work on them on a case-by-case basis, and they're tailored to your processes, your compilers, languages, library versions, test environment, and of course, the safety standard that you're working with. And they result in a set of qualification documents that you present to the authorities during the standard auditing for achieving the safety standard. And the benefit to using a custom tool qualification kit is, of course, that gain trust in using the tool. You're validating the tool's behavior, ensuring it has a low defect rate, and making sure that the tool itself was created keeping in mind the safety standard. And for teams, the saving comes in when we talk about time and cost. Creating these custom reports when it comes time for auditing can take significant time, and manual qualification can result in overlooked errors, which add to project costs. And I think one of the biggest things is just the peace of mind that comes when you are going through safety standard auditing. So if you work with safety critical applications and want to learn more about these tool qualification kits, I definitely encourage you to contact us. That about wraps up everything I want to talk about. We've gone for about 45 minutes. So just some additional information for you. Our homepage is froglogic.com/Coco for Coco's homepage. I definitely encourage you, if you haven't already, to get a evaluation version of Coco. It's completely free. It has unlimited support, and it's fully featured with the latest version of Coco. So you'll get everything that we talked about today, including the new function profiler and everything. And like I said, they're fully supported. So you can reach our support team at any time for help. If you want to learn more about the technical details, our online docs are at doc.froglogic.com. And if you're looking for other webinars, like for the Squish GUI tester, we rotate our webinars on a weekly basis. So I suggest you take a look at froglogic.com/support/webinars. You can contact our support team anytime at squish@froglogic.com. Again, my email is my first name, Nicholas@froglogic.com. And we're on Twitter, Facebook, LinkedIn, and we post to YouTube. So I encourage you to follow us there. And if you'd like to get our newsletter or get the latest new product releases when they happen, send me an email and we can get you signed up for our newsletter. So that is about it. I know I've talked a lot. Sorry about that. So we'll have time for questions now. So feel free to ask any questions you have. I'll give you guys a couple minutes to type those in. Let's see. One question that came up is the difference between Coco and GCov. So I can answer that for you. So GCov is can be pretty limited. For example, its coverage level support is limited to statement and branch coverage. And as we saw earlier, Coco supports both statement and branch coverage, but also condition, MCDC, and MCC coverage. Another thing about GCov is that it has pretty limited compiler support. It works only with the GCC compiler, whereas Coco has much wider compiler support. That test impact analysis feature for patch analysis that I showed you is supported by Coco, but not by GCov. And also, GCov reports on the coverage with HTML reports that display the source code with the coverage information, but Coco does produce pretty detailed HTML reports, but also has the coverage browser for interactive coverage analysis. So those are the big things. Let's see. Someone had a question about unit test frameworks other than CPP unit being supported. So I showed CPP unit today, but Coco itself was built with a very open and flexible approach in mind when it comes to integrating with external test frameworks. So we have documented setups for framework integrations like CPP unit and Qtest and Google Test. but you should know that virtually any generic or even atypical framework can be supported. So taking CPP unit as an example, CPP unit itself has no knowledge of Squish Coco, but the two can integrate based on the way the tests themselves are written. If you're looking for a how-to guide on your own unit test framework, check out our Squish Coco blog. We do have a how-to guide on how to integrate virtually any generic framework for use with Coco. Okay, I don't see any more questions. So I think we can stop here unless there are any more. Okay, we'll end it for everybody. Thank you very much for attending. And let me know if you have any questions.